Welcome to All Space Considered, everyone. I'm David Reitzel, and with me tonight is Chris Butler and Katie Flynn, Jared Head, Bill Gruneberg, and also Haley Bricker will give a very special presentation via video. But we've got a great show with a lot of us telling a lot of great stories tonight. So let's get right to it. First of all, this is All Space Considered, which we have the first Friday of every month. And you can see our social media connections there. Feel free to connect with us on social media. We'd love to hear from you. And that's where you can find us. All Space Considered is produced by Griffith Observatory, which is, of course, run and operated by the Department of Recreation and Parks in the city of Los Angeles. So we like to thank everyone there. And also, we want to make sure we thank Griffith Observatory Foundation, who's our nonprofit partner, who helps us out in so much of what we do. So tonight's show, Friday, December 2nd, we are almost, but not quite, coming to you live from Griffith Observatory. We do have some of our team members there, and I think the folks in the depths of space might even be able to hear us if that streaming's been turned on. But we're still not quite in the Leonard Nimoy Event Horizon Theater just yet. So we're still coming to you remotely, but we're glad to be able to come to you at all because we've got a great show for you tonight. We're going to talk about the year in review with a twist, meaning that we're going to update some of these stories if there's any new information. And the stories that we all decided were sort of the biggest ones for us this last year were JWST being launched and successfully providing just amazing images. The image of Sagittarius A star, and if you don't know what that is, well, stay tuned, you're going to find out. And of course, all the amazing stuff that's happened on Mars. And then lastly, a wild card, the DART mission. We really felt that it was just something different that you don't see every day, and yet really important. I can't say how important it really is. The dinosaurs would really appreciate a mission like this. That's what I'll say about it if you don't know what it is. Then Katie's going to show some of the best pictures from the year and some that have happened this month, and also talk about some of the biggest solar system weather events, so sun weather stuff. So that's going to be terrific. We'll have a sky report from Patrick that he pre-recorded. He couldn't be here tonight live. He had obligations to make sure the Samuel Ocean Planetarium is in top-notch shape. So he and Matthew are both have prior obligations, unfortunately, but we shall carry on. Chris is going to bring an Artemis report. If you don't know, we being the United States, NASA did launch a great big rocket that had a new spacecraft on it, and it all falls under this new title of a mission called Artemis. And Chris is going to give us an update about what went on with that so far and what to expect a little bit. And then we're going to turn to Jared. He always gets to bat cleanup with here, just about bat cleanup. And he's going to tell us about some of the launches this month with Out to Launch. And then we're going to finish the show with a video all about our amazing guests that we had throughout the year. We just want to make sure we thank each and every one of them. And we thought, well, what better way than to show them, give them a chance to say things in their own words once again and show just really how terrific those segments were and how thankful we were to be able to have those guests with us. So, well, anyway, that's our show for tonight. Our YouTube audience, those of you that have YouTube accounts, if you log in, you can chat with us on the chat, and we do like to answer questions there. So that's where we take a lot of our audience questions. So if you're wondering when I say we have a question from our audience or our chat room, I'm talking about the YouTube chat, and you too can join that if you have a YouTube account. It's not too hard to join, and it's a lot of fun. Well, anyway, onwards and upwards tonight. I think I've covered all the bases. Have I forgotten anything? I don't think so. I'm looking at my colleagues. Chris is saying no. Anyway, so let's begin our favorite topics of 2022 that we got to cover. JWST, the James Webb Space Telescope. I'll say it up front once. And there it is, beautifully deployed. This is an artist rendering of JWST. It is an infrared observatory, hence those big shades that were designed to block the sunlight from it and keep it cool, have all the heat radiate away from the big mirrors that were up top, and the electronics and everything down below that creates heat could be kept away from it via these big sun shields. So incredibly complex satellite, really, or spacecraft that we were sending out. It did launch. It was launched on a European Ariane from French Guiana on December 25th, 2021. So it was launched at the very end of last year, a little more than a year ago, but it was on Christmas Day. So those that celebrate thought of this as a great gift for all spaceflight fans and all fans of astronomy, thinking there goes our telescope. Here is that sun shield deployed in a lab, of course, so you can see how it compares to a person. It's about the size of a tennis court, and there are 5 layers. Craziness. It's really amazing how this stuff worked. The mirror itself is enormous. You can see how it compares to a person and how it compared to the Hubble Space Telescope mirror. Now, this was 18 individual segments. Now, how do you have 18 segments all make a single image? Well, what you have to do is align all of those mirrors. You have to tip and tilt them until they all point to the same position and bring all those dots together. And you can see sort of an actual little movie of that happening. Those stars are coming into a focus and each becoming a single dot on each of the mirrors. And then, of course, these same tools can be used to sort of take an image of the mirror itself. And this is the alignment selfie. So we could say, yep, there they all are. And we are seeing light in all of them. Sort of the first light image that we got to see, the alignment evaluation image. Everybody was still very excited about that because boom, diffraction spikes, those big spikes that are coming off the star in the middle, the 6 big ones, and then the sort of smaller horizontal one. Those are due to the optics of the instrument, the telescope and the instrumentation. So it was a good sign to see those and to see them look so sharp. It was really incredible. Now here's a comparison of an old space telescope, Spitzer, that was retired. There's the Spitzer image, and here's the comparison of the James Webb, JWST rather. Catch myself saying the whole name. And here's the image of JWST's image, how much sharper that is. It's like putting your glasses on. It's really quite amazing. Now you can see a couple of the measurement for the ground segments on the left-hand side, or ground measurement on the segments, and then a recent best mirror alignment. Well, you can see that one in the lower right that has that spot. What's going on there? Well, it turns out there was an impact. A micrometeorite came in, impacted that mirror, and actually damaged it. So this is something we knew could happen. We were a little worried. I think everyone was somewhat surprised it happened this early on. So they are going to take some actions to try and prevent this, and namely that's pointed away from where these things come from. Only observe in the other direction. And it does turn out that there is a preferred direction to have these micrometeorites come from. They can come from anywhere, but in general, they're going to come in the direction that the Earth is moving in its orbit, because the Webb telescope travels along with the Earth in the orbit around the sun. So you want to point away from the direction you're heading. It's kind of like it'll observe out the back window, the back window of the car as we're driving, rather than looking out the front. Now, here's one of the beautiful images it took, of course, one of my favorites. This incredible structure we're seeing in the nebula, the Carina Nebula, of course, the cosmic cliffs as they call it. And we're peering deeper into it, seeing pockets of star formation that we'd never seen before. Of course, it released these other beautiful images as well. Here's the Stephan's Quartet, which, believe it or not, only 3 of those galaxies, or the 3 up top, are actually at the same distance. The one that's on the left-hand side is not at the same distance. It's in the foreground, and you can see that in the imaging. It breaks into individual stars, whereas the others do not. Took some images of dying stars. These are what are called planetary nebula, and this is the Southern Ring Nebula, and it's just a gorgeous image of the death throes of a star, where it's throwing off its outer layers, and those layers are glowing from the heat from the inner star that's dying on the inside. You're seeing these deeper layers that are still very hot, and that outer glow from that gas. The Webb also has a spectrograph on it, and you're able to measure things like this atmosphere of an exoplanet, a planet going around another star. We were actually able to see in some of the very first imaging the composition of an atmosphere, and it'll just keep getting better. And in that first imaging release, of course, they released this beautiful image of the cluster. And everybody was, of course, just loving the galaxies that are in this. You can look at the little tiniest thing in here, and it's probably a galaxy. Some of these are some of the earliest objects that we're forming. But meanwhile, that cluster in the foreground has that big smear and swath of light. Let me take the laser pointer here and show you what I'm talking about. You can see here this loop that comes up over and goes around. Well, it was kind of confirmed that that indeed is probably intracluster stars, stars that have been ripped out of their galaxy in the foreground cluster, sort of creating this background glow, or foreground glow as the case is in this image, because most of the galaxies are in the background. Speaking of background galaxies, they were measuring Z's, which is, it's a measurement of distance, really. It's how many times the light has been redshifted. It's the redshift of the galaxy. And the bigger the number, the further away it is. And needless to say, a Z of 20 is something like 13.5 billion years ago is when the light would have had to have left it. And people were claiming those sorts of redshifts off these objects. I do think that we need, I need to go into the literature and find, well, what are the actual spectroscopic measurements? We're going to need to start taking some spectra of these if we can, if they're bright enough, and find out, really nail it down, because most of these estimates were based upon colors of the objects, which colors can change depending on dust and stellar composition and other things. They're pretty good, but we can do better with spectroscopy. Speaking of spectroscopy, JWST is outfitted with an instrument that can do spectroscopy. That's the NIRSpec instrument, and others. MIRI's in there as well, and it can do what's using called an integral field unit, where you can get a little spectrum of each and every pixel, or at least ones that you've chosen in a range. Needless to say, look on the very bottom, crossing it. I'll get my laser pointer out here again. BVRI, well, B stands for blue. That would be the blue color eyes see. V is sort of a green band, visual or green. R is red, and of course, yellow and orange are in between. So the JWST, it can't see green or blue at all. It's not very good at seeing yellow or orange or plain old red. And most of the images, most of the instruments have the vast amount of their sensitivity in what's known as the infrared, or the wavelengths that are slightly longer than plain old visible light, just so you can see what sort of instruments available. There were some problems with the MIRI instrument, but it turns out that it's back up and running and working just fine again. They found a workaround to make it work better. I want to end here just with a couple of beautiful pictures of the Tarantula Nebula, which is actually a star-forming region in our neighboring dwarf galaxy that orbits our own, the Large Magellanic Cloud. So the Magellanic Cloud is a dwarf galaxy that goes around our Milky Way, and it has its own stars that are being formed in it. And this is a dense region here that are forming stars. And JWST was able to make these spectacular images. And this is the MIRI instrument taking an image of that same region. I'm not ending here quite yet. Of course, I've got Neptune to talk about, and that beautiful image with the ring that we talked about before. And you can see here that that's Triton and other moons with Neptune there glowing ghostily. There were other images of galaxies at other distances, other galaxies fields have been taken. And finally, a couple to round it up here. I keep wanting to end the section. I feel like I've been talking a long time. The Spitzer telescope, again, that previous infrared telescope's on the left-hand side, and JWST with NIRCam is on the right-hand side. Now you might look and say, well, what's that sort of fuzzy stuff that's in there? Well, if you zoomed in on this image, you'd notice that those are individual stars, and we're actually looking through a dwarf galaxy. And JWST is able to break this dwarf galaxy into single stars, which is pretty darn cool. It can see baby stars being formed. This is actually a star forming region, and this is a single star with a dark disk going across it, and material flowing off the poles of this new stellar system that's being formed. JWST is able to measure chemical compositions in atmospheres, and you can see here one of the papers where they did that. These wiggling lines in the right-hand part over there really is a spectrum, and you can go and fit it. And the amazing thing here is that they were able to see SO2 which is sulfur dioxide. They didn't expect to see that, but they went in and did find it. And sulfur is an important element for life. So this planet probably doesn't have life, but it's interesting being able to start to piece apart these atmospheres of planets going around other stars. This is, I mean, this is, okay, not quite Star Trek level stuff, but as a kid, if you were telling me we were measuring the composition of atmospheres from a spacecraft we had deployed, I mean, this is awesome, awesome stuff that the Webb is able to do, JWST. So you can see here how it can go from hydrogen sulfide down to sulfur dioxide. And anyway, I'm going to move along to the final images finally. Just very recently, the NIRCam instrument was used to image Titan. Titan is a moon of Saturn that has a nitrogen atmosphere. Now, Titan is one of my favorite moons. I've always thought, how cool is that? The atmosphere is almost all nitrogen. That's what Earth's atmosphere is. It's almost all nitrogen. We got some oxygen in there too, which we need. Ever-growing CO2, which isn't so good. But Titan, all that nitrogen, well, maybe we could just add some oxygen and we could go live there. Well, problem is it's freezing cold. It is so cold there, methane and ethane turn into a liquid. So they're not even gases. They liquefy, and it does have, it rains methane, ethane. There are seas of it. It has a whole hydrological cycle, and JWST can see clouds in the atmosphere and surface features of this moon of Saturn from its location using its infrared instruments, which are just incredible. You can see there cloud A and cloud B that they feel are up, you know, again, up in the atmosphere, and then that we're seeing down to the surface, and we're able to see sort of surface colorizations down there. So I never thought this new telescope would be able to see features on a moon of Saturn this clearly and be able to sort of follow clouds going around it. So just amazing stuff. You know, I find it really exciting to live in this era with this new telescope. Yeah. So now we also had gotten some other very exciting images. So Haley, are you excited about the new images of the Sagittarius A star?
I'm so excited to talk about the image of Sagittarius A star that was released earlier this year in May. So folks might remember the state-of-the-art image that was released of M87 star, the supermassive black hole in the nearby giant elliptical galaxy M87. So this was taken by the Event Horizon Telescope Collaboration, or EHT, back in 2019. So this was a massive scientific achievement because up to this point, only images of stars influenced by the gravity of a black hole had been captured, which is somewhat indirect evidence of their existence. And so while technically we aren't imaging the black hole proper, we are able to capture direct evidence of it in the form of its shadow, or the event horizon, which is the central dark blob in this image of M87 star, as well as the glowing dust and plasma that accretes around it. And so if we didn't think that imaging just one black hole was enough, astronomers went and did it again, but this time they pointed their telescopes to the center of our own Milky Way galaxy. And so not only was this an additional feat of observational prowess, it really helped astronomers sort of gain closure on a widely held assertion that there is a supermassive black hole at the center of our own galaxy, giving us finally direct imaging evidence to add to our pile of other clues. So when I mentioned earlier that we only had indirect evidence of stars being influenced by the gravity of a nearby black hole, I'm talking about the black hole at the center of our own galaxy. And so to give you some context, astronomers first started to suspect a black hole lay at the center of the Milky Way in 1918, when astronomer Harlow Shapley observed strange stellar orbits and clustering of stars near the center of the Milky Way. And so later generations of astronomers were additionally perplexed over radio emissions coming from the same location, which pointed to evidence of some mysterious and massive stellar object. So perhaps a black hole? At this point, black holes were just a theory recently posited within the framework of general relativity. And so it wasn't until real-time observations of stellar dynamics conducted much later in the late 20th and early 21st centuries that showed there indeed seemed to be something quite massive exerting gravitational control over these stars, and that these motions could best be explained by the presence of a supermassive black hole. And so we call this black hole Sagittarius A star, the one at the center of the Milky Way. In this GIF, you can see a compilation of observed motion of stars in the center of our galaxy, orbiting a shadowy, invisible object in the center. And so remember, actual observational evidence of black holes remained elusive. This does not give us a picture of a black hole. So earlier this year, several All-Space Considered producers and myself were able to attend the Pasadena meeting of the American Astronomical Society, where an entire press session was convened to present and discuss the newly released images of Sagittarius A star. This was so exciting to attend because it provided an in-depth and nuanced understanding of why these images were so important, and also from some of the people who actually did the work. So first and foremost, we learned that Sagittarius A star is a fundamentally different black hole from M87 star. First, Sagittarius A star was a much harder target. It's smaller, so about 1,000 times less massive and much dimmer. So this might seem a little funny to comprehend because even though we call black holes like Sagittarius A star supermassive, it's still 27,000 light years away, which means the apparent size in the sky is very, very tiny. So combined with its smaller size, the dimmer luminosity, and being quite far away, this presents an additional observational challenge. And so in this image, comparing the first black hole, M87 star, to Sagittarius A star, you can see how the two compare in size to one another and to our solar system. So secondly, Sagittarius A star is very, very active, changing on the order of minutes to hours. Conversely, M87 star was much more stable, with its accreting material taking days and sometimes up to weeks to show perturbations. So that meant there was relatively little difference between imaging sessions of M87 star, but quite a lot of variability in the case of Sagittarius A star. Additionally, the light leaving the black hole is distorted by gas and dust lying between the Milky Way center and our location here on Earth. And so this creates sort of a hazy effect when trying to get a good image. You can think of it sort of like trying to look through frosted glass at things on the other side. You just can't really resolve it with your eyes. So because of these two interferences, images of Sagittarius A star were pretty hard to pin down, and images cannot be trusted at face value to begin with. So this means that some images captured might look weird and wonky, showing structures that maybe aren't really there because they came out blurry due to distortion and variability. And so in order to get around these barriers, the Event Horizon Telescope collaboration uses a few techniques. So one observational and one computational. So first, in order to just capture enough light from these very distant and apparently small objects, the EHT uses very long baseline interferometry, which allows the use of multiple telescopes across the globe to resolve objects in the sky. So the EHT collaboration uses about 8 telescopes spanning between the South Pole and Spain at different longitudes around the world. So this allows for constant light collection of the black hole, even as Earth continues to rotate, because multiple telescopes will be pointing at the object at all times. And so what this does is it turns Earth effectively into one large telescope lens. So in order to make sure that the structures and features being resolved by the EHT telescopes were both real and detailed, astronomers had to come up with clever statistical imaging algorithms. This allows astronomers to determine the likeliest structure resolved by the telescope. The model was created from years and years of observing light scattering in images from the black hole and the effect distortion has on them. So millions of simulated test images have been produced via supercomputing in order to build out the robustness of this model. And in the end, the model can be used to deduce the most likely common structure of Sagittarius A star across all the observing nights. So here is an image of Sagittarius A star produced by averaging together thousands of images that were taken by the EHT telescopes and processed using the statistical model. So along the bottom row are 4 composite images and histograms, or bar graphs, showing the relative number of images with similar features produced from these simulations and where they fall in the total distribution of all images taken. And so you can see the far left images show the bulk of the images that were produced by running them through the statistical model, indicating that simulated images do not tend to show non-ring structures, which further indicates that the observed images of Sagittarius A star are reliable. So only a few fall on the right-hand side of the distribution, showing things that probably weren't really there. So the results are absolutely gorgeous. And so while they might look like incoherent blobs of golden haze, Sagittarius A star clearly shows an accretion disk, which is the ring in these images. The resolution of the ring can shed some light on the orientation of the black hole. So a slightly tilted axis of rotation relative to our line of sight will result in an asymmetrical ring, which basically means one side of it's going to look brighter than the other. The brighter part being where matter is moving towards us, the viewers, and the dimmer side being matter moving away. So you can sort of start to parse out some rotational features. And so the more pronounced the tilt is, the more asymmetrical this brightness or ring feature will appear to us. And since these images clearly show a closed ring, astronomers were able to deduce with the help of the statistical models that the rotational axis of the black hole must be tilted no more than 30 degrees from our line of sight. And so I think these images are such a testament to the collaborative nature of science. So after all, it did take 8 distinct telescopes around the entire world, the people powered to operate them, the astronomers and data scientists to create statistical algorithms and process them, think deeply about them, and then present them to the world cohesively. This is no small feat by any means, which is why I think Sagittarius A star is worthy of a 2022 look back.
Wow, well, that was just a very informative segment from Haley. Thank you very much for all of that. Gotta love that Sagittarius A star image and what it shows us. Moving on to Mars right now. I saw we had some questions in there, but I don't have answers for you. I don't know how bright the black hole would be if it was in orbit. It would probably fry all of us because it's a super massive black hole and we wouldn't want. Anyway, good question, but I don't have a great answer for you. If it were like at lunar orbit, we'd be dead. Anyway, moving on to Mars. We talked about Mars quite a bit this year, and we tend to. In fact, we were lucky enough to kind of start off the year. Our February show, we had Dr. Matt Golombek. He was one of our wonderful guests this year. So don't forget, stay tuned till the end of the show tonight, where we have a special video where we're going to show you all our special guests that we had and let them speak for themselves. It's going to be a lot of fun. And I also want to take a moment here just to promote our foundation. If you join our foundation and you make a donation, everybody that does so, I was told, gets a ticket to a special event that's happening in December. And that special event is going to talk all about how we're inspiring kids. Really, at this point, we can do it worldwide, although it's designed to inspire kids in California. And you're going to get to see behind the scenes footage of our online school programs, experience bits of the program, although they're going to be a little bit tweaked for you. We're going to make them special. And you can get a ticket for that if you join our foundations. I just wanted to give everybody, make sure you knew that opportunity was there to get this free ticket. So moving on with other things we've done, another thing that we provide for you for free is the Sky Report. Patrick, every single month, talks about the sky and what's up in it. And oftentimes Mars is up in our sky, and he has told you where to go look for it. And right now, Mars is at opposition or coming very close to it. And in fact, on the 7th, of December, 7th of this month, Mars is going to do something special. And on the 8th, it's going to do something special. So stay tuned for Patrick's Sky Report, where he's going to tell you all about that coming up in our show. But Mars has certainly been in our Sky Report over and over. Mars has a bunch of landers that have landed on it in the past. Perseverance and Curiosity are the two that are still roving and are active. And also Insight, the lander, I'm going to talk a little bit about here in just a second, tell you maybe a little sadder of an update. Well, on Mars, we got weather updates every single day from both of the Insight lander, but also from Perseverance. And you can see here back on March 23rd, 2022, it was actually kind of a nice day, 22 degrees Fahrenheit, not too windy. Again, the atmosphere is only about 1% as thick as Earth. So even on a highly windy day, it's not going to blow your cat away or anything like that. And let's check out today and see what it looks like. Well, in Jezero Crater, we've been there 633 sols, which is a single day on Mars. The high today was all of 3 degrees Fahrenheit. The low is minus 120 degrees Fahrenheit. Yeah, bring your extra blankets. Perseverance didn't just give us the weather, measured the speed of sound on Mars. And what's interesting about that is below about 400 hertz, where isn't middle A like 410 or 420, something like that? Anybody in our chat know what A is? I thought it was around there. So it's interesting, it breaks at that point. But above that, the speed of sound on Mars is 537 miles per hour, and above 400, it's 559 miles per hour. Here on Earth, at sea level, it's 761, but it's for all wavelengths, all sounds. So imagine what it sounds like on Mars. Things must sound really strange. Well, lo and behold, NASA, of course, has made a website where you can go listen to what it sounds like. Just type in and Google, sounds on Mars. What does it sound like? You can listen to birds. You can listen to a bicycle bell. Birds nearly go away. You can't hear their chirp at all. It's very, very strange. A is 440. Thank you, Judy. But it's interesting. It's close to A. Perseverance should also be known is this rover that we sent to go take samples. It was supposed to go to these positions, look for locations that could have had life in the past, do as much investigation as we possibly could, and then find good samples to store, to be retrieved and brought back to Earth labs where we can really, really study them and find out, is there life or not? This is a spot here called Yori's Pass, where again, we're seeing sandstones that were made up of individual pebbles that were brought from long distances, all sorts of different rocks. So fascinating rocks that are here where we're able to measure things from many different locations, and the rocks themselves were brought from different locations. You can see dark rocks and light rocks, volcanic rocks, and again, sedimentary rocks like sandstone. Perseverance has been measuring all of these, and some of the most interesting ones that we've gotten samples of have had these sort of veins going through them. Now, why do we care about veins? It isn't just that they're neat to look at, as you can see in this image. It's that they formed after the main rock. The main substrate there that's sitting there was formed at a time, and then it cracked open. And then water flowed down in there and brought those other minerals. So it gives us a picture of Mars at two different times: the early time when the main rock formed, and then a much later time when those minerals were deposited in there. And that later time, we're discovering those minerals could have droplets of water sealed inside of them, for all we know, a very small amount of water, which could be a sample of what the liquids were like there. We're also seeing evidence in these samples of organic compounds. Now, organic doesn't mean life compounds, but life does need organic compounds. So, and life can produce organic compounds as well. But we can't tell with Perseverance whether these organics were left behind by life or whether they were left behind by other natural processes. All we know is they're interesting. We've taken samples, we can bring them back to Earth, and maybe there's enough information there for us to be able to tell that, yeah, this most likely formed by life. It's possible. This is the right sort of habitat. It was liquid. It had sunlight. It had the right elements. It had sulfur. It had so these are exciting times. This is what Perseverance was sent to go do, and it's actually taking these measurements and taking these samples. So very exciting times in 2022 with Percy. Now, less exciting, although expected, was our poor InSight lander. InSight was sent to Mars with such high hopes of, we're going to measure earthquakes, and we're going to have this mole that's going to drill down inside, and we're going to listen and measure the temperature distribution and really kind of study the insides of Mars with this kind of off-the-shelf lander that used parts that were from, like, the Phoenix lander had parts that were very similar to this. So it wasn't an expensive mission in the grand scheme of things. But today, those panels are now covered in dust. The poor spacecraft is not getting enough energy, and we expect it to be shut down. It could be any day. It could already have been shut down for all we know. Maybe that's the last announcement is coming. However, let's celebrate some of the things it did do. It measured earthquakes, or Marsquakes as the case is. Here's one of the biggest ones it measured. So it was able to study the interior of Mars. Turns out that the crust is a little thinner than we expected, kind of two crusts. There's an upper crust and a lower. Turns out that the core, that deep down inside there, is larger and more liquid than we expected it to be. Now, still, it's cooled off, we think, so it must be mixed up. That iron core probably has other elements mixed up in there trying to keep it liquid. So very interesting. Here's the seismometer there that it placed with that cover over it. But I also just love this animation of multiple images. It's not an animation as in we faked it. It's they stitched it together. You can see the clouds passing by. That's what that brightening and darkening is. You're actually watching the high clouds pass on Mars, which is pretty amazing from this little lander. Here, the lander was actually able to measure a couple of impacts. And those impacts came from space. A little object came flying in, made a crater on Mars, and those waves travel through Mars, those earthquake waves essentially, or impact waves, and InSight was able to measure it. So this impact here was measured and detected by the lander, and here it is again, and you can see the white stuff that was thrown out of there is very likely to be frozen water. So that's probably frozen water ice. If you took an image of the same crater later, that's fun to say. If it did that, the white frozen water will be gone. You won't see that there any longer. So one of my favorite missions on Mars or recently is of course Perseverance, but I wanted to update you about InSight and the sad news, but it did accomplish its mission. So quite exciting. So Bill, are you around to talk about one of your favorite missions?
I sure am.
Yeah, that wasn't. Was it all that you hoped it would be?
Yes, and more. Much more.
Yeah, much more. Okay. Well, I can't wait to hear all about it.
Okay. This is the DART mission. This is the one that might save all our lives someday. It is the double asteroid redirection test. And I should get to that slide. There we go. Okay. The double asteroid redirection test. And this is the first time we've ever tested a planetary defense strategy. Planetary defense doesn't mean aliens coming here and, spacecraft. It means big impactors, things like asteroids that could slam into us and do lots of damage and even destroy a lot of life. Just ask the dinosaurs whether they were happy that they didn't have a sophisticated space program. They didn't, they were not. So this image actually shows the components of the thing. The thing, you can see the two asteroids, Didymos and Dimorphos. Didymos is the big one, Dimorphos is the small one that orbits Didymos, and you've got the DART mission flying in, and behind it you can see off to the left there, that little thing, that's a little CubeSat made by the Italian space agency. Called LIVESTREAM, and that's how you say it in Italian anyway. I don't know how you would say it in English. And what that does is it hangs back. It's separated about 15 days before the impact, and it takes pictures. So we have a lot of good images of the impact from that. And then down below you see a picture of the Earth with an observatory blown up. That's because there were lots and lots of ground-based telescopes. I'm going to get to that image here. There it is. You can see how many, the list of worldwide ground-based telescopes that watched and monitored this thing. And off to the left, you see Hubble, JWST, and one more, Lucy, which are space-based. So there was a lot of attention paid to this thing. Here is a good little schematic of what happened. You have Didymos in the middle, Dimorphos orbiting it, and you see the DART mission just zooming in there to run into the smaller Dimorphos asteroid, and then see what it can do. Can we move an asteroid? Can we redirect an asteroid is the question. So I'm going to show you, let's just show you a video now. This is the video of the actual event. You have now, I'm going to tell you, this DART mission is like about 1,300 pounds. And the object it's going to hit is something like, what is it, I have the number here, 5.5 million tons. The asteroid that's being hit, the smaller asteroid, is about the same size and mass as the Great Pyramid of Giza. So we're getting in closer and closer, and there's that big object. That's not it. We got to hit this little one, and bang, we did it. Here's a picture pretty close up of what it looked like. And then here is a picture of, this is the last actual image that it took, the craft itself, on its way in before it smashed into the asteroid. And of course, it was a bullseye. I like to say it was a smashing success. Bullseye is a dart pun, and I know smashing success. I'm sorry, that's the last of my puns. But it really was just a much smaller object that hit a much larger object. And now the trick is, did we actually make some impact on it? And it turns out we did. What they were trying to do was, by hitting the asteroid head on, take away some of its momentum, its angular momentum, or its orbital velocity around the bigger asteroid, which would mean it would fall into a lower orbit and go around a little more quickly. So the amount of time that it takes to do one orbit should go down if we're successful. And what they were hoping for was a change of 73 seconds. That would be 1%. And if they could get 73 seconds shorter orbit, that means there's a success here, and that this is actually something we can employ if we need to. But they expected to get, maybe by calculations, up to 10 minutes. You know, math and physics are great, but sometimes you have to go there and find out what you can really do. What they got was not 10 minutes, not 73 seconds. They got 32 minutes of shorter orbital period for Dimorphos going around Didymos. So it was a really, really, really great success. And there were some unexpected results, some fun stuff. You can see here the bigger asteroid and the asteroid that was hit with stuff coming off of it. There's all these tendrils of stuff. The way the stuff flew off of the asteroid surprised some scientists. They didn't necessarily expect to see this. There's another image. Here's a really good image. These were all taken by the Italian CubeSat. And you could even see the impact and some of the distribution of the matter in the Hubble and the JWST space-based telescopes. And then we have a Hubble image that shows the actual impact in a GIF, just, you know, getting hit and throwing stuff off into space. Oh, and this is one of my favorites. The next one coming up is, let's see, I believe this was the Atlas group. It's a group of telescopes, but it's a little video or GIF. And there it is. That was the impact. And you can see the amount of stuff that was just blown off the surface of the asteroid Dimorphos. What happened to a lot of that stuff is what happens with comets. It created a tail. You can see in this image there, just if you look very closely right in the center, this is from our telescope demonstrator, Blake Estes. Great guy, great astronomer, great telescope operator. He now operates a pretty major observatory down in Australia, and he got this image of that tail forming. And the tail seemed to form the same way that comet tails form. That is, there's all this stuff flying off the sun, the solar wind, particles just flying off into space, and they push the matter back until it forms a tail. Okay, so that's great. So here's another picture of the tail. Here's another picture of the tail. All kinds of telescopes took pictures of the tail. Here is you can see the virtual telescope. I love this group of telescopes. And there it is if you didn't see the actual tailed asteroid there. But something else that happened that was interesting is the tail started to split. It became kind of a double tail. And I think that at this point, still, nobody really understands exactly why that happened. Comets often have a double tail, but that's because the stuff that comes off a comet is some gases and some dust. So they react differently under the pressure of the solar wind and make two different tails. This is all dust, so we don't really know exactly what's going on there. Finally, this isn't it. We're not done. I mean, there's probably more data even gleaned from this to go through, but there's going to be something called the Hera mission that will follow up. I believe it's going to launch in 2 years, in 2024, and arrive in 2026. I'm pretty sure that's the timeline for this. And it wants to go back and study these two asteroids more carefully, look at whatever crater might have been made in Dimorphos, and learn what it can about the internals of asteroids, as well as just, you know, the surface stuff that we normally study. And the way that's partly what it's going to have is a radar instrument that will be able to actually look inside. So it's really interesting stuff. 4 years away, but I promise you, absolutely promise you, when it happens, we will cover it, and we'll remind you what happened back here. And it was just a really terrific mission. And like I say, it can save all our lives.
Well, you know, Bill, I'm mostly on board with that, but I still feel it's a little bit like innocent asteroid going about its business. Out of nowhere comes this spacecraft from Earth, assaults it, blows the heck out of it, changes its environment, and then we're going to return to the scene of the crime.
I hear you, man. You
That's,
know,
you know,
I hear you.
it just feels like we're,
You know, I hadn't thought of it that way, but we might have hurt its feelings. You're 100%
Yeah.
correct.
We certainly changed its orbit.
Yeah, we changed its orbit. Luckily, the orbit was not changed in a way that this smaller one can come back and hit Earth. They're nowhere near Earth that way.
They picked this little system for that reason. It wasn't headed toward us anyway, and there's no way this impact could have made it head toward us. It was, you know, on too different a trajectory. So
exactly.
Are we?
Somebody in chat, are we the bad guys? It's exactly, are we the baddies this time? I'm thinking about. Anyway, well, thank you for that report. The DART mission, indeed, like if the dinosaurs had DART, maybe they would have been able to think about how to change, you know, the asteroid coming in, a healthy observing program. You need to find them before you can redirect them. So let's make sure we're funding these, you know, all sky surveys. They're going to be able to go find them.
Yes.
Well, speaking of all sky, Katie, what you keep your eye to the sky, scouring the internet and looking for all things pretty. And what do you have for us this month in terms of space weather and beautiful images?
Yeah, so we've had some beautiful images throughout this past year that I'm going to show some of my favorites. This first one is 5 images of 5 different stars taken by Griffith Observatory telescope demonstrator Anthony Perkic. So we see Betelgeuse, Sirius, Antares, Procyon, and Arcturus in this image. And then from another telescope demonstrator, Todd Kunioka, this is Jupiter and Saturn in front of or behind Face Rock from Joshua Tree National Park. This was taken in August. And then a stunning image by Blake Estes. This was in September. This is Sharpless 1 in Comet 2017 K2 Pan-STARRS. And then we have the moon with Venus. This was taken by Jordy Coy. And of course, JWST's beautiful image of Jupiter I had to keep in here. And then just some beautiful pictures of the city and the observatory. This one was taken by a museum guide, Jared Donkersley. And David Pinsky, who also gives us beautiful images, took this of downtown LA with Mount Baldy in the background. And then to move on to some of my favorite cloud pictures, this is the sunset in Santa Cruz. This is a little GIF that's looping. This was taken by one of our producers, Daniel Perea. And these are my favorite clouds. These are lenticulars. This is by Dario Gianoble. And another Anthony Perkic image. This was above Griffith Observatory. You can see that halo there with the bird flying through. That was just a beautiful image. And then I showed this gigantic jet a few times this past year. This was one of my favorite finds. And what's cool about this jet is this 5 months after it was taken, this green ghost that you see in the middle of the image here was sighted, and that was for the first time ever. This is from Space Weather that green ghost had been sighted. So that was something really cool from this past year. We also had a lot of noctilucent clouds. This is a June reading here from Space Weather, and we were able to find some beautiful images of those noctilucent clouds. This is Dr. Adrian Janetta, and this is from the UK. And then the stunning image also has aurora in it from Jared Eicher. I believe that's how you pronounce his name. And then, of course, I had to include this image. This is actually noctilucent clouds on Mars. This is from Curiosity. And then onto some space weather. So this is a plasma twister. I can't recall what, oh, this was June 21st of this year, which is our tornado 20,000 kilometers tall, twirling hot plasmas that it says here. So that was something really cool to see this year. And then this was the largest sunspot as of May of this year. This one was 123,000 kilometers across, I believe. This was sunspot AR 3014. And just to give you a little visual of the distance there. You can see the Earth and Moon and how big that is right in the center below the sun. And then finally, this is today. This is sunspot AR 3153, and it's rotating in the sun's southeastern limb. And it's a huge sunspot that we're seeing today. So 2 dark cores that are wider than Earth. And then just to take a look at the solar cycle, this is the sunspot count for each year, and we are headed towards solar maximum. So you can see 2022, we've had only 1 day of no sunspots this year. And some of my favorite aurora photos from this year, this was Evan Zucker, who I believe went to Alberta to see these. And this one's Göran Strachan, who always takes incredible images of aurora. I believe he's in Sweden. And this one I love because it's from the Upper Peninsula in Michigan with the bridge there. You can see aurora right above it. This is by Mary Beth Kaczynski. And then finally, a more recent image. This is from November of this year. And this is from Oliver Schwen, who also takes incredible images of aurora and other things as well. So I just want to say a big thank you to everyone that allows us to use their photos and show them during All Space, because it's a pleasure to be able to show them.
Yeah, absolutely. Couldn't agree more.
I do think you probably should say, though, that when you say green ghost, you should make it clear that's a nickname.
That it's not an
unusual atmospheric phenomenon, rather than getting us into the National Enquirer.
That is true.
Yeah, well,
atmospheric phenomenon.
But Bat Boy has strong feelings about the green ghost, so just we'll be interviewing Bat Boy in next month's presentation. Well, thank you, Katie, so much for that space weather. Those aurora photographs make me want to become an aurora chaser. The videos and photos, I've only seen them once before, and they were spectacular, although nothing close to what we're seeing here. And it's just crazy. Now, what's neat is the aurora are actually tied to the solar cycle, and the more active the sun is, the more likely you are to have the conditions right to get the aurora. So, but certain times of year are a little better than others. So if you really want to go see them, plan it out, do your research, and don't just say, I'm heading north, I'm going to go see an aurora. You might not have that much luck. But speaking of seeing, well, let's take a look here at what we have to take a look at.
Hello, and welcome to the December 2022 Sky Report. Here's what's happening in the sky of Southern California. Looking to the evening sky, the most prominent object to the east-southeast is the red planet Mars. Mars is in Taurus the Bull. The brightest star in Taurus is Aldebaran, an orange star. Above Aldebaran is the beautiful Pleiades star cluster. This cluster is best viewed with binoculars. The left horn of Taurus connects to the constellation Auriga, a chariot driver. Capella is the brightest star in this constellation. Here is a challenge. I took this picture of the same area of the sky as shown in the previous graphic from Griffith Observatory last month. See if you can spot Mars, Taurus, the Pleiades, above the bright city lights of Los Angeles. I've drawn in blue lines to make it easier to see. This image shows Taurus, Pleiades, and Mars above the trees. The right horn of Taurus is partially hidden behind trees, while Capella is just above the treetop. For the last few months, Mars has brightened up, nearly 5 times brighter on December 1st compared to September 1st. This is due to the Earth catching up to Mars on its inside orbit. Earth is closest to Mars on December 1st. At that time, Mars is at maximum brightness. On the 7th, Mars opposition occurs when it's in line with the Earth and Sun. The close distance of Mars to Earth is a great opportunity for amateur astronomers to take detailed images of Mars. This image was taken in late October. The northern polar ice cap and surface features are clearly visible. On the night of December 7th, when Mars is at opposition and still bright, there is a lunar occultation of Mars. This is when Mars disappears behind the moon and reappears an hour later. The Mars occultation happens while the moon is full. As shown in the purple shaded area, the Mars occultation is visible over most of North America and parts of Western Europe. The times when Mars occultation occurs depends on your location. As seen from Los Angeles, Mars is about 1/4 degree from the moon's eastern limb at 6 p.m. Pacific Standard Time. At 6:31 p.m., Mars begins to disappear behind the moon. An hour later, Mars emerges from the western limb of the moon. The Mars occultation is over. At 8 p.m., Mars is about 1/4 degree west of the moon. Weather permitting, Griffith Observatory will stream the Mars occultation live through telescopes on the roof. Please join us for this unique event. A week after the Mars occultation, the annual Geminid meteor shower occurs on the night of the 13th to the morning of the 14th. Under clear dark skies, 150 meteors per hour are expected, but rates will significantly decrease by bright moonlight after 9:54 p.m. on the night of the 13th. Looking towards the south in the evening, the bright planet Jupiter is visible to the southwest. Jupiter lies between two constellations, Pisces the Fishes and Cetus the Whale. During the middle of the month, Jupiter sets just after midnight. While Jupiter is ready to set, Mars ascends high in the southeast. From Los Angeles, Mars is nearly overhead around 11 p.m. in the middle of the month. Below Mars, the brightest stars sparkle from the winter constellations of Orion the Hunter, Gemini the Twins, Canis Minor the Lesser Dog, and Canis Major the Great Dog. Speaking of winter, the winter solstice occurs at 1:48 p.m. Pacific Standard Time. This is when the sun rests at the most southern point on its annual path or ecliptic around the sky. The motion of the sun along the ecliptic happens when the Earth moves in its orbit around the sun, and it appears that the sun travels around the sky along the ecliptic. At local noon from Los Angeles, the sun is about 34 degrees above the south horizon, the lowest noontime altitude for the year. The December solstice marks the beginning of winter in the northern hemisphere and the beginning of summer in the southern hemisphere. On December 28th, 4 planets and the moon are visible in the evening sky. Low to the southwest, the brilliant planet Venus is about 1 degree from Mercury. Both planets are about 6 degrees above the horizon, 40 minutes after sunset. Above Venus and Mercury, you can still catch a glimpse of Saturn in the fading twilight. Saturn sets just before 8:30 p.m. Above Saturn, the near first quarter moon is located below the brilliant planet Jupiter. This arrangement of planets and the moon is a fine sight towards the end of the year. Our moon phases this month. Full moon is the 7th, last quarter is on the 16th, new moon is on the 23rd, and first quarter is on the 29th. And that's all for this month's Sky Report. Until next time, cheerio.
Cheerio. How I love the fact that Patrick ended the Sky Report with cheerio this month. Patrick couldn't be here tonight. He is working hard with Matthew to make sure the Samuel Ocean Planetarium is up and functioning the way it should be and is in top shape. We have a state-of-the-art, world-class star projector in there, and we have the experts from Germany in town, and Patrick and Matthew have been spending night times making sure that star projector produces the most realistic sky that you can get in any planetarium anywhere. So when you come to Griffith Observatory, you're going to get the best. But still, Patrick took the time to record this. He does this every month, however, that we load it to YouTube. So we're running his YouTube one. If you want to make sure you don't miss these, subscribe to our YouTube, become a subscriber, ring the bell, as people love to say. That way you'll get notifications and told as we post these. Katie's involved deeply with what we're loading to all these channels, and we're looking to keep bringing more and more content. Speaking of content, there is a spacecraft up there in space right now that's making us all quite content with the state of that program, I'll say. But Chris, what's it all about? What's happening out there?
This is as exciting as anything possibly could be for someone like me who's a big fan of human beings exploring other worlds directly. The last time human beings did that, go to another celestial body, I was 8 years old. I have been waiting since then for this to happen again. We've talked about it, we've dreamed about it, but tonight, as I speak to you on December 2nd, there is a brand new spacecraft of NASA developed in cooperation with partners around the world, which is 250,000 miles away from the Earth tonight, completing day 17 now of a 25-day planned shakedown mission for the next spacecraft to carry astronauts to the moon. It's actually happening right now. If you didn't notice, you didn't know about it, we've got lots to report. Now, there's no crew on this flight. This is a test flight of the vehicle. The idea is to send the new Orion spacecraft out to the moon to perform distant loops beyond the moon, the farthest any spacecraft designed for human beings has ever been, and then test it out there, make sure it works, and then it comes on back to the Earth on December the 11th. This is a critical test because the next flight, Artemis mission number 2, is scheduled to take astronauts to orbit the moon, and Artemis III is scheduled to take astronauts to the surface of the moon. The big moment we waited all these decades for, it's been 50 years, now is a critical test. And the question is it working? Well, first things first, here's a look at the orbit where you see the moon in green going around. The spacecraft went out, used the moon's gravity to fling it out beyond the moon. So this is technically orbiting the moon now. This is where we are tonight. It's going to come back on December 5th. It'll swing by the moon again. The moon's gravity will deprive the spacecraft of orbital velocity, and it will come back to the Earth for a very rapid splashdown in the ocean. Again, it passed the moon. The moon flung it out to just about 300,000 miles from the Earth. Then we'll come back in December 5th. We pass the moon again. It slows the spacecraft down, and it comes back to the Earth. That's the overall mission. The first part of the mission was also a critical test, not only of the Orion spacecraft that sits on top, but of the Space Launch System, NASA's new mega rocket, the most powerful rocket that is operational in the world, the most powerful since the Saturn V moon rocket, yes, more powerful than the space shuttle, if you remember those from ancient history. And the question is, how did the rocket do in its spectacular night launch on November the 16th? The launch was very successful. Everything worked the way we thought it should. The initial results for the performance of the launch vehicle is that everything's right down the middle of the highway. Everything is very good. This means that NASA will almost certainly, barring any surprises, certify the Space Launch System, which is what the rocket's called, to carry human beings on Artemis II. Now, it isn't just the giant first stage of the rocket that needed to be qualified. There's also the second stage, which you see here attached to the Orion spacecraft. Now, the actual spacecraft that will carry the people is the conical-shaped vehicle all the way on the right side of your screen. On the back of it, and this is important because we'll talk about this too, is a small grayish cylinder right against the back of the Orion. This is the European Service Module. It has important components in it that generate electricity and supply oxygen and water to the astronauts. So it serves the crew in what we call the command module, the Orion itself. Now, behind that, oh, and you can see it has solar panels on it as well. But behind that is the Interim Cryogenic Propulsion Stage, or ICPS. It's the top stage of the SLS rocket, and it had the critical job on this mission of firing to propel Orion into a trajectory to the moon. This is an incredibly important part of these missions, of course, and the report card is in, the ICPS, right on the money. So that too is cleared for use on Artemis II. Inside the spacecraft, we don't have astronauts. We do have a mannequin and some other test articles of different kinds. Looking here at the life protecting capabilities of the spacecraft, in particular protection from radiation. Remember, this is much, much farther from home than the International Space Station. Radiation levels are greater out here. We want to make sure that that works. And then, of course, we're checking all of the systems inside the Orion spacecraft, the computers, navigation, all the rest of this. There was a bonus on this flight. Inside that second stage ICPS I mentioned, there were, and you can see them here mounted inside part of the second stage, the CubeSats. There was a series of 10 smaller scientific payloads that were ejected into space. Now, unfortunately, not all of those worked as intended. There was a Japanese small lander spacecraft that was actually going to land a robotic probe on the moon. Unfortunately, that one didn't work. Some of the other ones did, but the main thing is for future work with this space system, we know that the CubeSat launching capability of this rocket, it's so powerful, can launch so much into space. It's not just the Orion that's being launched, but up to 10 or whatever scientific payloads can proceed independently to the moon or out into the solar system. That's been proven. The pictures from this flight, well, I was 8 years old, but I remember what it looked like, and I'm glad to see pictures like this again. Here's a picture of the Orion spacecraft and that critical service module with an engine on the back of it on screen left. Notice the inset picture. Those of you who remember your ancient history, that is what we call an OMS pod, OMS, for orbital maneuvering system. Those were on either side of the tail of the space shuttle. That was a very important rocket. It's the same rocket. It's the same type that's on the service module for the Orion European service module. This is also something that really had to be tested and really had to work. Why? That's the rocket that fires to return the crew to Earth on Artemis II. So, and all future Orion missions to the moon. So that was a very important test objective. That's one of the reasons they used an engine we were already familiar with. Looking at this, the spacecraft actually makes 2 close passes by the moon. As I told you, we are right now closing back in on the moon right now for a December 5th pass around the back side of the moon. So that's where we are in this diagram. We are a long way from home. Pictures like this, if they don't jolt you with surprise, they should. The farthest this vehicle got, well, nobody on board, but designed for people, is almost 300,000 miles from the Earth. Look at the size of the moon from here. This breaks the previous record for a human-rated spacecraft that was set in 1970 by Apollo 13. Next time, there'll be a crew on board. And I can only imagine what they're going to say looking out the window, seeing things like this. There's something else we had to test, communications. We're farther from home than we have ever been with a human spacecraft, and that means the Deep Space Network, the 3 big antennas, radio antennas at Goldstone, at Madrid, and at Canberra, all have to participate, plus the tracking and data relay satellite system in geosynchronous orbit that supports the space station and so forth, and radio telescopes on the ground. They did have a 40-odd minute communications glitch with the spacecraft, but it turned out that was actually a ground problem. So they fixed it very quickly, and they don't think that'll be a problem in the future. But the thing is, all the elements of the mission for the future have to be worked out. And now the big test, the biggest of them all, the heat shield. We flew the Orion spacecraft once in December of 2014, partly to test the heat shield, but it turned out they entered at a slower speed, less energy than they would do on regular moon flights and on this moon flight. So now this time on December 11th, we're coming in hotter, faster than we did before. This heat shield must work or nobody is getting on board in Artemis II till we fix the problem. Then, of course, we have the parachutes. They have to work. They worked in 2014. They have to work again. We have the splashdown. Yes, a splashdown, an old-fashioned splashdown. This time not in the middle of the Pacific Ocean. It's landing right off the coast, San Diego. We might in California even hear the sonic boom when the spacecraft comes in. We have to practice all of our recovery procedures to get the vehicle back into the Navy ship and so forth. No crew on board this time, but we'll practice it just like we did in 2014. Where do we stand? The answers so far, all good. We are go, go, go everywhere. The Space Launch System is probably guaranteed to be certified for humans. The ICPS looks good. The European Service Module is humming along nicely. The engine that will have to bring the astronauts home on Artemis II performed very well and will do so again in a couple of days. Life support is good. Communications are good. The last two things we got to ace, that heat shield, the parachutes, the rest of that, and recovery operations. So here's where we are. We are not in the situation I used to hate when you talk about space missions and say some of you kids in the audience may someday grow up to go to the moon. No, actually, astronauts on Artemis II, a year and a half from now. This is a picture of of Artemis astronauts staring at the Space Launch System and wondering who's going to be the first crew to go back to the moon since 1972. And that's a year and a half from now. And then, hey, at Artemis 3, one of these people in the picture may get to walk on the moon. I'm as excited as I have ever been about anything and thrilled to tell you it all seems to be going very well. That's my report.
Well, that is great news from the Artemis mission. I have to say, my excitement for this mission is increasing with each time. I was also blown away by those photos of the moon being nearly the same size as the Earth, as the spacecraft is way the heck out there. I was like, whoa, we're not kidding around with this. So,
and remember, we're not just talking about test pilots. Remember, for all my science friends, some of the people going back to the moon are going to be PhDs to conduct science on the moon.
Yeah, science and engineering to learn how to live there, how to work there, how to do things in space. It's going to be just amazing, absolutely amazing. Now, I've heard people talk about the rivalry between China and NASA and the United States to get back to the moon. And I loved somebody's reply that I saw just this week saying, well, I'm not sure if you've noticed, but NASA has a spacecraft in orbit around the moon right now, the one that's going to take people there. So if you're paying attention, this is where things stand right now. But nonetheless, China has still been doing launches. They're still a powerful spacefaring country. And Jared, are you around to tell us a little bit about in your Sky Report, maybe what China's got going on, as well as some other things this month?
Oh, yes. Yeah. In fact, it seems that November was China's month where they kind of came in and upstaged everybody just a little bit in what they were doing. And China's lunar ambitions are a little bit different than the United States's, where the United States is more about sustainability, while China is more about the technological development that they can do for their missions. And going back a little bit, on October 31st, we had the launch of Miang-10, which was a science module that is going to be used, or actually is being used on board already. It launched on that ultra powerful Long March 5 rocket. Just looking at this absolute massive vehicle heading on up. This is China's heavy lift rocket, so essentially the equivalent of a Delta IV Heavy or a Falcon Heavy here in the United States. It did eventually make it to the core module of Tiangong, which is China's space station that they have in orbit right now that is crewed. They do have 6 people on board of it right now. And we'll actually talk a little bit about that crew expanding once we get to it. It was moved around on station on November 3rd, just 4 days after arrival. They went ahead and detached it from one portion of the station and moved it over to another, essentially docked it on the 31st to make sure everything was working over a couple of days, and then put it where it was supposed to go, where it then deployed a massive solar array. And much like the International Space Station, you can actually go outside and see Tiangong flying over while it's in orbit. So feel free to go on a website like heavens-above.com and check it out and you can actually get those predictions to see when it will go right over you. Of course, this great view of it right here, a bit sped up with that time lapse. We don't actually dock things that, even China doesn't dock things that fast in space. Everybody obeys the laws of physics just the same, no matter where you come from. Now, the booster of that rocket, the first stage, ended up getting this tweet from the U.S. Space Command, which is to say that they can confirm that the People's Republic of China Long March 5 rocket body re-entered the atmosphere over the southern central Pacific at 4:04 Mountain Time on November the 4th. For details on the uncontrolled re-entry impact location, we once again refer you to the People's Republic of China. I really like that tweet because it just sounded like U.S. Space Command was like, stop calling us, go talk to them. They're the ones who did it. So just stop messing up our phones and just go talk to the people who actually did it. Now, obviously, if you have a space station, you've got to keep it very well supplied. For the International Space Station, we have a multitude of vehicles to do that. But for China, they have one. They're Tianzhou, and they actually had a launch of Tianzhou 5 on November 12th. Now, what was so impressive about this flight is that China is essentially reaching a level that the United States and Russia are at in operations with their spacecraft, where Tianzhou 5 only took one orbit, so 90 minutes from launch to dock at Tiangong 1. That is very impressive for somebody just entering into the game. Even about a decade ago, it would often take a Soyuz or a supply ship to take about 3 days from launch to arrival at the International Space Station. But now we're doing it in one orbit. So I guess if you really want to get your In-N-Out burger still warm while it's up there, we can do that now for you. Just kind of looking at Tianzhou 5 here, detaching from its Long March rocket, and then eventually approaching the Tiangong station here, which you can see over on the right with Tianzhou 5 on the left, right there. There it is, a beautiful spacecraft in orbit there around the Earth. So dropping off a couple tons of supplies, fuel, air, water, food, other things that the astronauts are going to need throughout their time, science experiments as well. And then there's a big one just a couple days ago, which the next launch was Shenzhou 15. Now, this launch was a crewed launch, and it occurred on November 29th. We have Commander Feb Zhulong, operator Deng Qingmeng, and system operator Zhang Lu flying in that Shenzhou spacecraft right there. This is pretty exciting because these are views that normally we don't get as observers outside of China. So this was pretty exciting to see them getting loaded into their Shenzhou and then finally launching. And launches we get to see all the time, but of course, we've got to make it look good nowadays since everybody's stepping up their visual game. So take a look at this shot that they got. That's a mighty nice one of their ambitions there, in case you're wondering what China is aiming for. Now, Shenzhou 15 also rendezvoused with Tiangong in one orbit as well. So again, just showing the technical competency of China in that they are not they're not a bunch of pushovers in their spacecraft. They're actually very, very good at what they do. And they joined the current Tiangong crew, which is Chen Dong, Liu Yang, and Cam Zhuji on board. And those 6 are going to stay together for a little bit, and then eventually the crew of Shenzhou 14 are going to come back to Earth, and we wish all 6 of them the best of luck while they are up there in space, and a safe journey home for all of them as well. So this is China starting its continuous presence, its own continuous human presence in space, and China has mentioned to corporate interests and also Europe that if they would like to jump on board as well, you're more than welcome to come along. Now, Rocket Lab, for our next launch, they attempted to recover their booster. They are attempting to try out reusability. They essentially did it not necessarily because they want to actually end up reusing them like SpaceX does, but because they figured out that manufacturing the boosters takes a very long time for them. So this would actually save on that and help build up the cadence that they have there for their flights. Now, of course, Rocket Lab, very well known for their cheeky names of their flights. This one was called Catch Me If You Can. It launched on November 4th, and Rocket Lab is doing a very interesting way of catching their rockets where they have a parachute that is then snagged by a helicopter. But unfortunately, on this flight, They could not get the helicopter close enough to catch it. It did land in the ocean, and they are going to take it back and study it as well. We move on. We actually come home to California, where we say goodbye to the Atlas rocket series. And this was on November 10th. This was the final West Coast Atlas V. So you're either there or you're just not seeing one, or you have to go to the Cape down in Florida to catch it. I was lucky enough that I was able to be there and watch it leave Earth forever. And it was lofting the JPSS-2 weather satellite for NASA and the National Oceanic and Atmospheric Administration, which we see it separating right here. Also had a special experiment on board called Lofted. Now, Lofted is actually a inflatable heat shield. So you were hearing Chris earlier talking about testing Orion's heat shield for lunar return speeds. Lofted here was actually to test if you can have a inflatable heat shield come back from speeds on orbit around the Earth. And an inflatable heat shield can be a lot more lightweight than a traditional heat shield, and that would be very helpful for going to places like Mars or Venus. And it turns out Lofted worked exactly as expected. So successful test with that, although we're going to take a look at the data coming over from that. Then we move to the East Coast, out to one of my favorite named launch places, Wallops Island, where the Northrop Grumman Antares 230 ended up launching the Northrop Grumman Cygnus NG-18, which they had named the SS Sally Ride in honor of the astronaut. This happened on November 7th. This is a supply ship to the International Space Station, although there was a little bit of a problem after the deployment of the SS Sally Ride, where one of its solar arrays actually did not fully unfurl. And in fact, we got some really great photos of it from the International Space Station in our next bit right here, where we can actually see the array sort of hung up on itself. And if we move to there we go. So that's a bit of a lopsided looking spacecraft, because it should have two solar arrays there, but only one deployed. Luckily, the Cygnus resupply craft only need one to operate. So we're going ahead and went to the International Space Station. A nice close-up there shows us that there is some sort of debris sitting there that has caused the solar array to not deploy. So Northrop Grumman's going to be taking a look at that issue, see whether it was something from Cygnus or something from their Antares rocket on the way up. But overall, it got there, got the supplies there, and it's going to be doing what it needs to once they release it in just a couple of months. Now, SpaceX, usually we talk a lot about SpaceX, but unfortunately, China kind of upstaged SpaceX with some of their stuff this month. And also SpaceX kind of slowed down a little bit too. I guess once they hit the record of 48 in a year, I guess they just decided to kind of lean back and take in the rest of the year. But we did have 5 launches this year, with that one on November 12th, hitting that mythical 52 launch mark that SpaceX have been wanting to reach in 2022. They are now at 54 launches, still several on the books for the rest of 2022. So we'll see if they can do it. I think if they can hit 60, I think it'll be right around 60 is where they're going to be at with that. That'd be a nice, good number for them. Now, they did send up the final cargo dragon, new fresh cargo dragon that's going to be coming up in this next beautiful shot here from the International Space Station of that vehicle. Also, another cargo resupply ship. SpaceX will no longer be manufacturing the cargo dragons. They'll actually just be reusing them because they're designed to be reused. And they've only also got one more crew dragon left to build as well. And then SpaceX is going to have an entire fleet of crew and cargo dragons to fly on a reusable basis. So very excited to see that. And then, of course, we have our own little launch place here in Southern California at Vandenberg. It's Vandenberg Space Force Base. And you've got a little bit coming up this month before the end of the year. On December 15th at 3:46 a.m. local, we have the Surface Water and Ocean Topography Mission, or SWOT. It is going to be measuring the height of bodies of water with the precision of 1 centimeter or better from orbit. And this is a NASA mission collaborating with some European groups as well. And then Also on December 28th at 10:58 p.m. local time, Eros C3. This is a military satellite for the Israeli Ministry of Defense. On December 28th, that launch for Eros C3, that one is confirmed that the first stage will be returning to landing zone 4 at Vandenberg Space Force Base, what we call a return to launch site landing. So that means that the first stage will actually come back and land within a couple thousand feet of the launch pad. So if you've ever wanted to see a rocket go up and then about 8 minutes later come back down right in front of you, that will be a launch most certainly to keep your eye on. And of course, I always recommend websites like Spaceflight Now or NASA Spaceflight have launch schedules on there. Launch schedules change all the time. So before deciding to make a trip, make sure that you check it day by day, sometimes even hour by hour on the day of, so that way you know what the status of that launch is. And that is your Out to Launch for November of 2022.
Well, a busy month once again. Thank you, Jared, for that fascinating report. And the Chinese have really stepping up the game there. So should be very, very interesting. I'm a fan of space. The more we go out there, the more we learn. I just hope everybody can share space peacefully is my hope. And we'll see if we can manage to do that. I think we're to the point now where we want to thank all our guests that came to All Space Considered throughout the year. So we put together this video of all the guests we had throughout 2022. I hope you all enjoy it. Let's take a look at who we were lucky to have visit us.
And the thing that we're looking for is bugs. We want an ancient habitable environment at about the same time that liquid water was stable here on Earth and life formed. And where's the best place to go? So the place that was selected is called Jezero Crater. Here is the flight coming back from that epic flight, if you will, 133. It's coming all the way back to the same place we started, and then it is landing.
So I'm going to talk about Aura Lyrae, the beating hearts of our Milky Way. Our Milky Way has many hearts, and we have discovered 200 of these hearts in our Milky Way, but others have found even more. And if you look closely at this image, I'm going to turn my laser pointer on and put it right next to one of these beating hearts, right to the left of my laser pointer. And they are pulsing in brightness. It's a time lapse and it's looping. Actually, even if it didn't loop, the stars loop.
Thank you very much for inviting us, and we're pretty excited to let you know just what we've been doing. The starting off of tonight's presentation by you folks actually was a compilation of 3 minutes that one of your folks did of 9 hours plus of videos that we took on our last balloon. So we really appreciate just that input that we've gotten from you guys. Regina wanted to roast me, so go and roast me.
Hi. Always tell me they have a problem with gravity, but I told them, just drop it.
One of the things we found that isn't Earth-like, but is super interesting, is planets in resonance systems. Resonances are where the orbital periods of the objects are related to each other with very simple mathematics, like one is 2 times the other or one is half the other, that kind of very simple integer. So this is a system that I really love called K2-138. So it has 6 planets around it, and they were all found by citizen scientists. The cool thing about this system is that the 5 inner planets are in a chain of 3 to 2 resonances. So again, the inner one goes around 3 times, the next one goes around twice. That one goes around 3 times, the next one goes around twice, all the way out, 3 to 2 resonances. Why that's cool is resonances are music. Now what's happening is every time a planet goes in front of the star, it makes a note. And the frequency of the note, the pitch of the note, how high the note is, depends on how fast it's going. So the inner planet is the one making the highest, most constant note. And then it goes out and out and out to the outermost planet, which is making the low note that just happens occasionally. And the reason it sounds pretty, the reason it doesn't sound discordant or out of tune, is because the planets are in resonance.
So the Hubble Space Telescope is still going strong, but the story of Hubble actually starts back in the year of 1946. And of course, everybody was celebrating the end of World War II at that time. And there wasn't a lot of knowledge about rockets yet. What people knew were the V-2 rockets that were used by the Germans to bomb Great Britain and what they saw in movies. However, in 1946, a very mild-mannered professor named Lyman Spitzer, who was at Yale University, he wrote a paper, and it was called The Advantages of an Extraterrestrial Observatory, or a telescope that would be put above the Earth's atmosphere. And he described what the advantages of those were scientifically. But he also made another very profound statement. And the profound statement in his paper was the value of this isn't just to expand our knowledge of what we already know, but it's going to discover these new phenomena that we haven't even yet imagined.
You go in here, there's a little tiny red dot. We actually got a spectrum of that smudge of light, and not only detected the galaxy, but saw some very clear emission lines here of specific elements like hydrogen and oxygen. People got really excited about this pair of lines out here due to the oxygen. Don't think anyone really expected to be able to see that. So we not only got a very, very deep image of the universe here, we're actually starting to get some very detailed physical information through these spectra. And if we're able to do it on that tiny dot of red light that you can't really even see in this big image here, imagine the richness of this that we're going to have when we're able to look at all of the thousands and thousands of galaxies in this image.
And I think that what horrified most people is that I had in my hand what every academic desires. I had a tenure track faculty position in my hand, and I let it go, right? And I said, no, I want to do something different. I thought the easiest thing to study was something that was equally quantitative in indigenous cultures, which was navigation by the stars. So what did I know about navigation by the stars before I started that research? Nothing.
So I'm going to be focusing on work that we published recently in Nature Astronomy on trying to image planets around other stars, specifically image planets still in the process of forming. And what this tells us about the diversity of planetary systems that the universe can spawn and how the solar system is common or unique. And we see evidence for these wide range of structures, where they may be clear cavities, spiral arms. All these, we think, are good telltale signs that protoplanetary disk is starting to incorporate some of this material into a planet.
Indeed, a big, big thank you to all of our guests. And speaking of thank yous, I'd like to have anyone that's in our crew that's around in our Zoom room here, go ahead and join. Turn on your cameras. I just want to thank everyone that helps make this show possible. Bill, wonderful segment. Jared, great segment. Haley, if you're here with us, I think there you are. Wonderful job with your report. Fascinating information. Katie, great job. Chris, great job. Patrick did a wonderful job with the Sky Report, of course. Matthew still worked on this show despite the fact he wanted the night off. He still helped us prepare for it. Brendan, are you there? Do we get to see you and anybody that's in the booth with you? Thanks to all the folks in the booth that make this possible for us to see and run. There they are. There's our booth folks. So thank you, everybody. Thanks to the whole team. Anybody I haven't mentioned, it's not that we don't appreciate your work, but we know that you're off doing other things, Daniel. So no, he's busy finishing up the semesters.
Oh, there you go.
And lastly, there you are. So anyway, I do want to also just thank our audience, all the folks on our YouTube chat, all our foundation members that tune in and support us. A big thank you for all you do. I want to thank the City of Los Angeles, the Department of Recreation and Parks, and Griffith Observatory as well for letting us do this program. It is a real pleasure and a privilege for us to be able to talk to so many great scientists, so many great science communicators, and it's a privilege for me to be able to work with all of you. So thank you so much for the great year, and we will return in January with a brand new show. So thank you all. And if you enjoyed this, maybe look on our YouTube channel on December 11th. about midday on Sunday, probably around 2 p.m., we're going to have our Apollo 17. Well, we're going to celebrate the 50th, and we're going to bring more information about Artemis. This time we're going to give Jared a chance to talk a little more in depth about the whole program rather than just the mission as we see it today, the spacecraft. He's going to tell us about, well, what's next? What is the next one's happening? So thank you all. Come on back later in the month. Come on back next year, and just thank you very much. So have a great night, everybody.
Thanks.